Let's be honest. Type 1 error, type 2 error, alpha, beta, false positive, false negative, these terms sound confusing to all of us until someone explains them properly. Once you understand one simple story, you will never mix them up again. So in this video, I will explain type 1 and type 2 errors in plain English, show you how they relate to statistical significance, and share the memory tricks that will help you answer paper B questions confidently. So let's get started. Type 1 and type 2 errors appear throughout research papers, randomized controlled trials, evidence-based medicine, paper B MCQs, and this topic is closely linked to p-values, confidence intervals, statistical power. Understanding type 1 and type 2 errors makes several other statistics topics much easier. So let's start with the null hypothesis. Everything begins with one assumption, that is the null hypothesis. And the null hypothesis simply says there is no difference or there is no treatment effect. Imagine you are testing a new antidepressant. The null hypothesis will then assume that the new drug is no better than a placebo. Now your study collects the data, and at the end you must decide whether to reject your null hypothesis or keep the null hypothesis. Sometimes you make the wrong decision, and that's where statistical errors happen. Let's start with type 1 error. A type 1 error occurs when you reject the null hypothesis, even though it is actually true. So in simple words, you think that you have found a treatment effect, but there really isn't one. And this is called a false positive. For example, imagine a study which concludes that a new antidepressant works better than a placebo, and hospitals begin prescribing this new antidepressant. Months later, larger studies show it actually offers no benefit. So, in that case, the original study made a type 1 error. It found a difference that didn't truly exist. Type 1 error is also called an alpha error. It is represented by the Greek letter alpha. Most studies accept an alpha level of 5% or 0.05. This means researchers accept a 5% risk of falsely concluding that a treatment works when it actually doesn't. And this links directly to the p-value threshold you have already learned in one of the previous videos. Type 2 error. It occurs when you fail to reject the null hypothesis, even though it is false. In simple words, a treatment really works, but your study fails to detect it, and that becomes a false negative. For example, imagine a new antidepressant genuinely improves depression, but your study has only 20 participants, the sample is too small, the study concludes no difference, the treatment is abandoned. Years later, a larger trial proves that it actually works. So in that case, what is the conclusion? The conclusion is the original study made a type 2 error. Type 2 error is represented by beta. Unlike alpha, beta is closely related to statistical power. So that brings us to statistical power. Power answers one question. If a real difference exists, how likely is my study to detect it? So power equals 1 minus beta. Most of the well-designed studies aim for 80% or 90% power. Higher power means lower chance of type 2 error. Now, there are several factors which affect power. Remember this part as it is one of the favorite questions in paper B. Power increases when sample size increases. Effect size is larger. Variability decreases and alpha level increases slightly. But out of these four, the biggest factor which influences power is sample size. Remember, larger studies have greater power. It's important that we understand false positive and false negative. So let's summarize. Type 1 error related to false positive, you think something exists, but it doesn't. Type 2 error related to false negative, you miss something which actually exists. So let me give you a memory hack, and this is my favorite way to remember it. Think of a fire alarm. Type 1 error means the fire alarm goes off. There is no fire. False alarm, false positive. Type 2 error. There really is a fire, but the alarm doesn't sound. That is false negative. Now you're never going to forget this. Let's look at some of the exam questions. A researcher concludes that a medication works when it actually does not. What error has occurred? It is a false positive, type 1 error. Another question, a study fails to detect a treatment effect because the sample size is too small. So, which error is this? It is false negative, so it is type 2 error. Candidates often confuse type 1 with type 2. Remember, type 1 creates a false discovery. Type 2 misses a real discovery. Let's quickly compare. Type 1 error, false positive, reject true null hypothesis, and it is the alpha error. Type 2 error, false negative, fail to reject false null hypothesis, and it is the beta error. Now, what is the relationship to p-values? Remember, p-value controls the risk of type 1 error. So, smaller the alpha level, lower the chance of type 1 error. But a very small alpha may increase type 2 error unless the sample size also increases. And this balance is another favorite paper B concept. Know these 5 facts for the exam. Type 1, false positive. Type 2, false negative. Alpha, type 1. Beta, type 2. Power is equal to 1 minus beta. If you know these, you will answer most of the MCQs correctly. Statistics doesn't have to be difficult. Once you understand the story behind type 1 and type 2 errors, the terminology becomes easy. Remember, type 1 finds something that isn't there. Type 2 misses something that is there. And don't forget, power reduces type 2 error. Master these concepts and you will gain easy marks in paper B exams. Thank you for watching. If you enjoyed this video, don't forget to subscribe to the channel for more revision videos related to paper A, paper B and CASC. See you in the next video.